When you walk through a city and pass a construction site with giant machines boring into the earth, what you may not realize is you're witnessing the birth of something massive beneath the surface. Today, we're diving into basement excavation using the board pile method, a deep foundation system that makes skyscrapers and underground structures possible. The journey starts with planning and precision. Engineers don't just dig randomly. The exact position of every pile is mapped based on soil reports and structural loads. Then, the site is cleared, leveled, and marked, ready for the heavy machinery to move in. The first big step is drilling. Using a rotary drilling rig, workers begin boring vertical shafts into the earth, sometimes 20, 30, or even 50 meters deep. These shafts are what we call board piles. They will become the invisible columns that hold up the entire structure above. Now, why use board piles? Because they are perfect for soft soil or areas near existing buildings. Unlike driven piles, board piles generate very low vibration and noise, protecting nearby structures from stress or collapse. As the drilling goes deeper, there's a risk that the sides of the hole might collapse. To prevent this, temporary steel casings are installed, or alternatively, a special fluid called bentonite is pumped in. This keeps the borehole stable, even in loose or sandy soil. Once the hole is ready, it's time to reinforce it. A prefabricated reinforcement cage made of steel bars is lowered carefully into the borehole. This cage gives strength and flexibility to the pile, allowing it to bear enormous loads while remaining stable during movements or minor earthquakes. But a hole and steel cage alone won't support a building. It needs concrete, and that's where precision truly matters. Using the Tremie method, concrete is poured into the borehole from the bottom up. This technique displaces any water, slurry, or air inside, ensuring the concrete flows smoothly and sets properly without gaps or weak points. No room for mistakes here. Once the pour starts, it can't stop. The entire column must be cast in one continuous flow to maintain structural integrity. After concrete placement, the top is trimmed to the required level. The pile is now hidden underground, solid, silent, and strong. The process is then repeated for all other piles on the site, following the same meticulous steps. Dozens, sometimes hundreds of these board piles are installed beneath a building footprint. They form the deep foundation system, ready to carry the immense weight of the structure above and resist the pressure of the soil surrounding it. But the story doesn't end with piles. Once they are in place, the real excavation begins. And that's what we'll explore, in part to how soil is removed, how retaining walls are used, and how the basement structure slowly emerges from a carefully engineered pit. With the board piles completed and secured beneath the ground, the next phase of basement construction begins: excavation. Excavating a basement isn't as simple as scooping out soil. It's a highly technical process that involves removing earth layer by layer while ensuring that nearby roads, buildings, and workers remain safe. As digging starts, the first challenge is the retention of earth. You don't want your excavation to collapse or cave in. This is where retaining walls come into play. In board pile basement construction, the retaining system is often built into the piles themselves. Once excavation reaches the first layer of piles, the sides are trimmed and cleaned, and shotcrete is applied to bind and protect the walls. Sometimes, steel struts or ground anchors are installed to resist soil pressure, acting like braces that hold the walls in place. Excavation continues in stages. After each depth level is dug, lateral supports are added. It's a method called top-down support. Dig a layer, support the sides, dig again. This reduces the risk of collapse and ensures that the structure remains safe even during heavy rains or high ground water levels. As we go deeper, excavation gets more precise. Machines like excavators, bulldozers, and loaders do the heavy lifting, but everything is monitored by surveyors and engineers to stay within exact depth levels. Eventually, the excavation reaches the final depth of the basement, which could be 3 meters. or even 20 meters below ground level, depending on the design. Now it's time to form the basement floor slab. A blinding concrete layer is poured first to create a clean, level surface. Then comes the waterproofing membrane, followed by reinforcement steel, and finally, the structural slab which ties the entire foundation system together. But it doesn't stop there. The vertical columns rise from the pile caps. Beams are connected. The first basement level is formed, then the next, and the next. Each level is built from the bottom up, floor by floor, forming the basement structure like layers of a cake. This technique board pile basement excavation is a blend of soil mechanics, structural engineering, and sheer coordination. One wrong move can lead to collapse, water ingress, or delays that cost millions. But when done right, it creates a basement that can hold parking lots, shopping malls, water tanks, or even earthquake shelters, all hidden below the surface, yet vital to the building above. From drilling the very first borehole to pouring the last slab of concrete, what began as a hole in the ground becomes a fortress of steel and stone. That is the power of modern engineering.